Here's the question. We have A, B, C, the events with the probability of A equals 0.5, probability B equals 0.2, and probability C equals 0.4. First, we want to find the probability of A union B if A and B are independent. What is independent means? So if A and B are independent, that means independent. That means the probability of A intersection B equals the individual probability A times probability B. So if I want to calculate the probability of A union B, this is probability of A plus probability of B minus probability of A intersection B. And now the A intersection B equals probability A times probability B. So this is 0.5, the probability A, plus 0.2, the probability of B, minus probability A times probability B. The final answer is 0.6. Part B. If A and B are disjoint, which is mutually exclusive, then the probability of A union B just equals probability A plus probability B, since they are disjoint, since they are mutually exclusive, which is 0.7. Now part C. If I have 3 events, they are all independent. Then how do I calculate this? First, we can let D, the event D, is A union B, which can make the question easier. Why? Because probability A union B union C then equals probability of D union C. Since they are independent from part A, the intersection parts, the probability of intersection equals the individually probability multiplication. So here I have probability D plus probability C minus probability D intersection C. But the probability of D intersection C is the multiplication of probability D times probability C. And what is probability D? D is A union B. Plus probability C minus A union B times probability C. Now the answer is 0.76. Part D. If A, B, C are pairwise disjoint. What does that mean? Again, we know that D equals A union B. So the probability of A union B union C equals the probability D union C. Since they are disjoint, pairwise disjoint, that means this is probability D plus probability C. which also means it's probability of A plus probability of B plus probability of C from part B, and this equals 1.1. This cannot happen. Since the probability is greater than 1. This is the exercise 1.